Hello?
Yes, sir.
Yeah, everyone can hear me, right?
Yes, sir.
Yes, sir.
Okay. Okay, so I'll wait for 2-3 more minutes. More people are joining. So what we'll be doing today is theory for vectors in 3D. I hope everyone has started revising the theory of this chapter.
Yes, sir.
Okay. So first, I will try to discuss what I want to talk about, and then I will give you a chance to ask any questions. Okay. So don't worry about your questions. We'll try to answer all your questions. But first, I will try to discuss what I want to talk. I will let you ask questions if you need some help in the middle. Okay. So we will not cover the entire theory. I'm going to talk about the stuff that is important and that is conceptual, which you need to know about. Okay. So pay attention. I'm recording the class, so it will be available later on YouTube. You can watch it later. And we'll start our discussion now. Okay. Is that fine for everyone?
Yes,
Yes, sir.
Okay, fine. So first of all, I want to talk about the concept of linearly independent and linearly dependent vectors. Independent and linearly dependent vectors. किनको आता है ये समझ में? सबको आता है ये? What is the meaning of this? If there are, let's say there are 3 vectors A, B, and C, when can we say that these vectors are linearly independent?
What are
sir.
linearly
XA plus 5V plus ZC equals to 0.
Yeah. A set of
Uh-huh.
vectors is called linearly independent if no vector in the set can be expressed as a linear combination of the other vectors in the set.
क्या वीडियो प्ले कर रहे हैं कोई? क्या है?
combination of vectors?
According to Superprint, a linear
Oh, sorry,
combination
sir.
of 2 or more vectors.
ये बंदा कोई वीडियो प्ले कर रहा है यहाँ पर मतलब डेफिनेशन में मैं पूछ रहा हूँ तो तुम लोग वीडियो क्यों प्ले कर रहे हो यार? हाँ, खुद से आना चाहिए ना, डेफिनेशन कहीं और से सुनना नहीं है। हाँ, वही मैं भी सोच रहा था कि ऐसे कौन बोल रहा है। एनीवे, इट्स फाइन। मतलब समझ में आना है। Okay, you need to understand the meaning of linear independence and linear dependence. Definition रटना नहीं है, ठीक है? So what is the meaning? If you write it like this, some scalar, suppose if LA plus MB plus NC is equal to 0.
Sir, I apologize for the earlier things. Actually, my little brother was near and he wanted to know what I was watching. So I apologize for that. So sorry. I will be.
It's fine, it's not a problem. I'm okay with it, but pay attention, okay? And try to understand the meaning yourself. You don't have to remember the
Sir, it
definition.
wasn't me, sir. I apologize for that. Sorry.
हाँ, ठीक है, कोई बात नहीं. So if this is equal to 0, where L, M, N are scalars, and if you can say that this is equal to 0 implies, this symbol means implies that all L is equal to M is equal to N is equal to 0. Then you will call ABC as independent vectors. So what is the meaning of this? The meaning is that if a combination of A, B, and C adds up to 0 vector, then all the scalars must be 0. That is the only way you can combine ABC to get a 0 vector. समझ में आ रहा है क्या बोल रहा हूँ?
Yes, sir.
If you can combine ABC to make a 0 vector, the only way you can make it happen is if all the scalars are 0, L, M, N, right? For example, I vector, J vector, and K vector you have already seen in physics. These are 3 independent, linearly independent vectors. Because there is no way that the sum of some pi plus qj plus rk will ever be zero unless all three pqr are zero. You cannot make it zero. The only way it can happen is if p, q, r or all three are zero, right? So that is the meaning of linearly independent vectors, that if the linear combination is adding up to zero vector, then the constants are also going to be zero, all of them. Linearly dependent vectors may, you can say LA plus MB plus NC is equal to zero vector does not imply that L is equal to M is equal to N is equal to zero. Basically, in this case, there will be a way in which L, M, N are not all zero. One of them is non-zero, and still you are able to arrange them in such a way that they add up to zero. Are you understanding what I'm saying?
Yes, sir.
All scalars don't have to be zero in this situation, right? So basically,
What you
uh,
said right now is for the linearly dependent vectors, right?
yes, for linearly dependent, if they are linearly dependent, then you can find some scalars L, M, N where not all of them are zero, and you can make LA plus MB plus NC equal to zero.
Okay, sir. Understood.
मतलब कोई सबको जीरो होना जरूरी नहीं है, ऐसा हो सकता है कि बिना सबके जीरो हुए भी you can make this whole thing zero, right? I
Yes,
hope
sir.
this concept is clear. This is a very important concept, okay? इस पे questions आ सकते हैं, so you should be aware of this. Now, another important idea related to this is this: a triad or a triplet of non-zero, non-coplanar vectors will be linearly independent. So basically, what we are saying is if you have three non-zero and non-coplanar vectors, they will always be linearly independent. You can think about it in a visual way also. Think about it like this. If this is x-axis and y-axis and z-axis, right? Think about the I, J, and K situation. The reason they are linearly independent is because they are in different planes, right? They are defining different planes. They are non-coplanar, three of them. All three cannot lie in the same plane, right? That's why they are linearly independent from each other. Any other vectors also, if you take, if they are non-coplanar, three vectors, let's say two of them are in some plane, this is A and this is B, and let's say C is like this. Think of this like this: A and B are in the same plane, but C is above the plane, right? Some angle. Then A, B, and C will always be linearly independent, because no matter what you do, you can never express C as a linear combination of A and B. I hope जो मैं बोल रहा हूँ समझ में आ रहा है क्या बोल रहा हूँ.
Yes, sir.
Yes, sir.
Suppose you have two vectors in the plane, no? तुम कुछ भी कर लो, x vector, y vector, कुछ भी scalars इसके साथ add कर लो, you will never be able to express a vector which is out of plane with it, right? You can never write C as a linear combination of x and y. Why? Why can't we write it? Because इसका vertical component कहाँ से लाओगे तुम? इसका
ये-
horizontal component तो ला सकते हो, लेकिन vertical कहाँ से लाओगे? x और y से तो out of plane part नहीं आएगा ना?
हाँ, sir.
I hope everyone is understanding what I'm saying.
Yes,
So,
sir. Yes,
as
sir.
soon as three vectors become non-coplanar, then that system is linearly independent. Okay. So this is an important idea. Hopefully समझ में आ रहा है सबको.
Yes, sir.
Yes, sir.
Sir, I have a doubt that the two
Hmm.
vectors will be always linearly dependent.
Right, because टू वेक्टर्स को तुम हर समय एक प्लेन ढूंढ सकते हो ना.
हाँ, yes, sir.
कोई भी दो वेक्टर लोगे तो उनको एक प्लेन, यू कैन मेक अ प्लेन थ्रू बोथ ऑफ देम, राइट?
Yes.
So two vectors will always be linearly dependent, right? But three
Yes.
vectors, if they are non-coplanar, they will become linearly independent, right? And
Yes.
इसी से related एक और theory है. The theorem says every set of four vectors will be linearly dependent. Linearly dependent. The reason for that, so what is the meaning? I'm saying no matter what four vectors you pick, it will always be linearly dependent. इसका बेसिक कॉमन सेंस रीजन सोचो कि अगर फोर वेक्टर्स लेते हो तो उसमें ऐसा भी हो सकता है कि थ्री आर नॉन कोप्लेनर, राइट? करेक्ट. थ्री आउट ऑफ दोज फोर आर नॉन कोप्लेनर, ऐसा हो सकता है, राइट? सो
Yes, sir.
these three will be linearly independent, right? Correct. For example, you can take simple vectors I, J, K. You can see that these three vectors are non-coplanar, right? Correct. And these three vectors are going to be linearly independent. But now, whatever fourth vector I pick, A, any fourth vector can always be represented in terms of these, no? Do you understand what I'm saying, everyone?
Yes,
Yes.
sir.
कैसा
Yes,
भी
sir.
तुम fourth vector लो, but if you have three non-coplanar vectors present in that system, then always you will be able to express the fourth vector in terms of those three, right? Correct.
Yes, sir.
And if you don't take three non-coplanar vectors, suppose you took a situation where no three vectors are form a non-coplanar system. So that means those three vectors themselves are dependent, right? Dependent on each other, right? Correct? So
Yes.
if they are dependent on each other, then the third one, suppose A, B, C you have taken and they are themselves linearly dependent, then obviously the third one can be written as X times A plus Y times B, right?
Yes, sir.
Yes, sir.
This is, by the way, the second case. We are not doing the first case. The first case is three are non-coplanar, right? I am doing the second case where no three vectors are non-coplanar, which means they are dependent, which means one of them can be written as a linear combination of the other two, right? अभी तक
Yes.
समझ में आ रहा है सबको क्या बोल रहा हूं?
Yes, sir.
Yes, sir.
Yes, sir.
तो फिर देखो कि मान लो तुम्हारा वेक्टर्स का सेट था A, B, C, D. Four of them were there. We are doing the case where A, B, C are linearly dependent. So C has been written as X times A plus Y times B. Here X and Y are scalars. So now notice one thing. You can write C plus minus XA plus minus YB is equal to 0 vector, right? Correct?
Yes, sir.
And we can add 1 times C plus minus X times A plus minus Y times B plus 0 times D is equal to also 0 vector. Do you realize now that this is a system that is now linearly dependent because there is a one non-zero, right?
Yes,
See,
sir.
the scalars are 1 minus X minus Y and 0. One of the scalars is non-zero, right? So that makes the whole set linearly dependent, correct? Because it is adding up to 0 vector, but one of them is non-zero, one of the scalars, right? I hope you are following what I am saying right now.
Yes, sir.
Yes, sir.
तो basically we have done the proof in both the cases. अगर ये 3 vectors were coplanar, right now we did that one, and if they were non-coplanar, then you can always write any fourth vector in terms of these 3, because you need only 3 vectors to define the full 3-dimensional space, right? You just need 3 non-coplanar vectors to define the full 3D space. You don't need anything else.
Understood, sir.
I hope if there is anyone who does not understood, please tell me. Otherwise, there is no point, right? कुछ समझ में नहीं आ रहा तो बता देना, right?
So, could you explain why does one make it linearly dependent again?
हाँ, because linear dependence का definition क्या था? PA plus QB plus RC plus SD is equal to 0 vector. अगर ऐसा है, then PQRS are the scalars, but not all of them should be 0, right?
Yes, sir.
That was the definition of linear dependence, that the addition is 0 vector, but not all of the scalars are 0, right?
Sir, right, sir.
तो यहाँ पे addition of C, A, B, D is 0 vector, but is all of the scalars, are they 0?
Oh, okay, sir. Got it. Yes, sir. Understood.
One of the scalars is 1, right?
Yes, sir. Understood.
Okay, so that is the idea, that any 3 non-coplanar vectors will be independent, and any 4 vectors, you don't have to worry about any case there. Any 4 vectors will always be dependent. I hope that much is clear to everyone.
Yes, sir.
Yes.
Yes, sir.
Okay, so the next topic that I want to talk about, see, I'm not going to cover each and every part of the theory. Some basic things I'm assuming you already know. I'm going to talk about the important points, okay? So I'm going to now
Yes,
go
sir.
to vector equation of a line. Vector equation of a line. So let's talk about it. So the standard vector equation is R vector is equal to A plus some T and B, where T is a scalar. Now what you need to understand here is what is the meaning of this equation. इसका मतलब क्या है, right? So first of all, you need to realize that here R stands for a variable or random point on the line. Random point on the line. And when we are writing R vector, we refer to the position vector of that point. So what do I mean by that? So suppose a line is like this. The origin is somewhere here, right? We have R is a random point on the line. This is the R vector, the position vector of a random point P on the line, okay? Usually, when you write the straight line equation also, if you remember in 2D straight lines, this is the standard equation of a straight line, right? And we say that point x comma y lies on the line, right? If it satisfies this equation, correct?
Yes, sir.
Yes.
So similarly here
Yes, sir.
also, this point R is like a point x, y, z, उसके components हैं. R vector is the position vector of a random point in space which lies on the line. And basically R vector could be written as x I cap plus y j cap plus z k cap. Right? This is a variable point on the line. Here A is going to be a point through which the line passes. So what is A vector? A vector is the position vector of that point. Do you understand what I'm drawing right now? A vector is the position vector
Yes,
of a point on the line. It is given to you in the problem. The problem will say a line passes through a point, and that point is A vector. Okay. So ये चीज clear होनी चाहिए कि sometimes we call a point as a vector. When I say a point is a vector, I mean its position vector. I hope everyone knows that position vector means line segment from origin to that point,
Yes, sir.
Yes, sir.
right? So
Yes.
sometimes I'll be calling A with A vector. When I'm calling that, then I mean position vector of A. But sometimes I'll be calling the segment AP as a vector. But then I will mean the difference between R minus A, right? I hope it is clear. When I say vector AP, I will mean R minus A. But when I say vector for A, what I mean is position vector of A from origin, right?
Yes, sir. Understood.
Yes, sir.
So dono meanings are similar and related to each other, and you should never be confused about it. So right now I'm saying a line passes through a fixed point, and they might also tell you that their line is parallel to a known vector B. Known vector B. So that known vector could be like this, something like this somewhere else. And the line is supposed to be parallel to B. So that means its direction will be same as the direction of B, right? Correct? So since we have that situation that the line is passing through A, but okay, I'll do it on the next page. So think about it. A line through A, there are infinite directions, right? Correct?
Yes, sir.
If somebody just gave you the information that line was passing through a point A, then there are infinite possible lines, right? So in order to specify a particular line, you need what? You need also the direction of the line, right? By giving the direction of the line. How do I give the direction of a line? Since we are working with vectors, we will say that the direction is parallel to a known vector. If I was working in 2D geometry, I would say that the line makes an angle theta with the x-axis, or slope of the line is something, right? The concept is the same. The way in which we are writing it is different, right? So what I will say is, if I know that the vector is parallel to B vector, then I need this particular line, not any other line. I need this line so that it passes through A point, origin is here, and there is another variable point on it P, which is R vector. This is my R vector. And I can say that this line segment should be parallel to B vector, right? So I can say that line segment AP, which will be R minus A, is parallel to B vector. And if two vectors are parallel, then they can be written as multiples of each other, scalar multiples of each other. That everyone should know. Do you understand what I'm saying right now?
Yes, sir. Yes, sir.
So therefore, R minus A is a T times B because it was parallel to B, and therefore the equation becomes R is equal to A plus TB. Right? So ये अच्छे से line equation समझना है. I hope it is clear to everyone what is the meaning of a vector equation of a line. Okay. The next
Yes,
point is, suppose they gave you line through 2 points.
So can
Line,
you understand this point by using the linear combination function?
vector equation of a line. It's the same thing. You are saying that R minus A has been written as a, you can say this, no, that R minus A and plus minus T into B is 0, right?
Yes, sir.
So here, these are dependent vectors, see? यहाँ पे
Yes.
1 time और यहाँ पे minus T. Minus T is obviously not going to be 0, right?
Yes.
So
Yeah.
you can say that they are linearly dependent also. Anytime you have parallel vectors, they will always be linearly dependent, right?
Yes, sir. Understood.
Okay, so line through 2 given points. अभी हम लोग ने जो देखा था वो था point slope form, right? What was the point? Point was A, slope was B, right? If you know straight lines in 2D geometry, you know point slope form of a line equation, right? It is y minus y1 is equal to m into x minus x1. I hope everyone knows this.
Yes, sir.
Yes, sir.
Yes,
What
sir.
we have written here is the point slope form, because slope was coming from the B vector, right? And point was the A vector, right? Now what I want is the 2-point form. In 2D geometry, 2-point form was what? Y minus y1 is equal to y2 minus y1 by x2 minus x1 multiplied by x minus x1. right? Correct? Here the slope was obtained from the 2 points by getting the slope from 2 known points. And then we are writing the same equation. Now, similarly here, what I will say is, suppose a line passes through 2 points, point A and point B. I need the equation of the line. Nobody told us the slope of the line, right? So what should I do now? Tell me. Line passes through 2 points. This is position vector A, this is position vector B. How should I get the line equation now? Anyone who understands this, tell me.
Sir, B minus A will be the parallel vector, and we can say that we can assume any random point on the line, say it R, and R minus A parallel to B minus A. So we
Right.
can arrange that.
So basically we are doing the same thing, but this time nobody gave us the parallel line. So we'll say that the line is going to be parallel to this direction, right? B minus A, right?
Yes.
So if it is parallel to this, we will take a variable point on the line and we'll say basically that AP vector is parallel to AB vector, right? So we'll say R minus A is parallel to B minus A, and therefore we can say R minus A should be some T times B minus A. And you're getting R vector is equal to A plus T times B minus A, right? I hope everybody is understanding that this is the same thing that we did earlier also. Nothing new has come, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
And you can see that this can be written also like this: 1 minus T times A plus T times B, right? See? And this is also similar to section formula, by the way, because you can think of it like this: 1 minus T times A plus T times B by 1 minus T plus T, which is 1 only, right? So think about it. This is also telling you that, okay, this means that the point P is being divided, or these are points in some ratio of 1 minus T is to T, right?
Yes, sir.
I hope you are understanding how it is. Section formula also looks like this only, right?
Yes, sir.
Yes,
So
sir.
what I want you to understand is conceptually समझ में आना चाहिए. You don't have to memorize anything. The only thing you need to memorize here is the basic line equation. R is equal to A plus TB. After that, everything is obvious and conceptual theory, right?
Sir, aren't we adding the directional nature also in the line? But line is no, a line has no direction. Like here we have written B minus A
You can
for
write A
parallel.
minus B also, no? What is the big deal?
मतलब T यहाँ पे फिर -1 मतलब उसके नेगेटिव हो जाएगा
It
फिर.
will be some other scalar negative of that.
Yes, sir. अच्छा
It
ठीक.
doesn't matter. Equation of the line is same,
Okay, sir.
right? बस स्केलर का वैल्यू चेंज हो जाएगा ना, और कुछ नहीं होगा उसमें,
हाँ.
right? So from here, if we understand all this, now we can easily write condition for T points to be collinear. 3 points to be collinear. Let's say you have 3 points whose position vectors are given to you. Obviously, though it is simple condition, you don't even need to remember also. You can say vector AB, vector BC, vector CA, or you can say you don't even need vector CA. You can just say AB is parallel to BC, right? Correct?
Yes, sir.
Do you understand that this much is enough to say the lines are collinear?
Yes, sir.
So you can say B minus A should be equal to T times C minus B, right? Correct? And let's simplify this a little bit and see what comes from here. So we'll get B minus A minus TC plus TB is equal to 0. So we'll say B multiplied by 1 plus T minus A minus t times c is equal to 0, right? Correct?
Yes,
देख
sir.
रहे हो ये क्या हो रहा है? Here these are scalars, no? See these scalars. X b, y a, z c, right? Where x is what? X is 1 plus t, y is minus 1, and z is minus t, correct?
Yes, sir.
Yes,
Can
sir.
you see that the scalars are adding up to 0,
Yes, sir.
right?
Yes, sir.
So basically, this gives you a very nice condition. It says that if you ever have a situation, if you have a situation where x times a vector plus y times b vector plus z times c vector is 0, and x plus y plus z is 0, where x, y, z were scalars, correct? Then what can we say? Then we can say that a, b, c vectors are collinear. Do you understand? We started from collinearity and we proved this only, right?
Yes, sir.
सबको समझ में आ रहा है क्या हो रहा है?
Yes, sir.
Yes, sir.
So we are getting a condition for collinearity. The basic idea of the condition was very simple. We said that if 3 points are on a line, we can always, using the 3 points, we can create two vectors, right? One vector will be AB vector, one vector will be BC vector. When we can always say that if they are collinear, AB vector is parallel to BC vector. And from there only we got this condition. But now if you remember this could come as a hidden information in a question. Like they will give you a question, they will not talk about anything about collinearity, and they will eventually ask you an option will be there, they are collinear or something. And the vectors could be more complicated than that, right? As long as the sum of the vectors is 0 vector and the scalars are adding up to 0, the vectors will be collinear. I hope everybody is understanding what I'm saying.
Yes, sir.
Okay, so that was about vector equation of a line that I wanted to mention today. Now we will come to vector equation of a plane. Vector equation of a plane. So here also you have to conceptually understand what we mean by a plane equation and all. So right now, first type of plane equation, अभी जिसने वीडियोस देखा होगा मैंने जो बनाया था प्लेलिस्ट में, तो उसको ये समझ में आ जाएगा, because all of this is explained in the videos in detail. But right now I'll go through the cases one more time. So I want the equation of a plane which passes through a given point and is parallel to two given lines. ध्यान से सोचो क्या क्या इंफॉर्मेशन है. 1 point and 2 lines, and the plane is parallel to the 2 lines, right? Correct?
Yes, sir.
So 2 lines will sort of give you a plane themselves, no?
Yes, sir. And to fix it, we will need a point from
So
which
let's
the point
think
will
about
be.
it. So let's say there is another vector B and there is another vector C here. And what we have here is the plane that we want is supposed to be passing through the point A. This is given, A vector. And it is supposed to be parallel to these two lines, right? So what we can say is, let's say this is my required plane, जिसका इक्वेशन अभी पता नहीं है, इसका इक्वेशन निकालना है, right? This unknown plane we need, right? Is everyone following what I'm saying right now?
Yes, sir.
Yes, sir.
So let's say I need the equation of the unknown plane. all the time in such questions, you have to take a variable point on that plane. Let's say P, which is R vector, is my variable unknown point on that plane, right? So now you can say that AP is a line segment that completely lies inside the plane, right? Correct? So AP line segment is a line in the plane, and since the plane was parallel to B and C, therefore we can say that AP vector should be parallel to or coplanar with B and C, right? Do you understand what I'm saying? These three vectors must be coplanar, no?
Yes, sir.
So if AP and B and C are coplanar, then there are many ways to do this part. Using triple product also you can do. You can say AP dot B cross C is 0. That is one way to do it, because coplanar vectors volume will be 0, right? Another way to do it would be
Yes, sir.
to do it like this. Because the vectors are coplanar, we can always express any one vector as a linear combination of the other two, right? Do you understand what I'm doing here, what I'm saying? Anytime three vectors are coplanar, they are a linearly dependent set, right? You can express any one of them as a combination of the other two. Correct?
Yes.
So therefore, right now I will do it like that and say I'm getting an equation like this. R minus A, which is AP vector, can be written as a linear combination of B and C. So here T and S are scalars. And we can write the general equation as R is equal to A plus TB plus SC. Correct? You should also understand that another way to do it would have been this way. So the equation may look different, but it captures the same information. Here I would have done the box product of R minus A with B and C is 0, right? That is also a different way of saying the same thing, no?
Yes, sir.
I hope everybody is following what I'm saying. These are both
Yes,
two
sir.
different ways, right?
Yes, sir.
Okay. Now we'll do some other cases of this. Case 2 is when we need plane through not one point, we are given 2 points and parallel to one line. Very similar to what we have done. So we want a required plane, but we already know 2 points on the plane, A and B, with vectors A vector and B vector. So my third vector is P, and I can always say that AB vector, AP vector, and parallel to a C. It was parallel to a line, right? So the line's direction is C. So what I can say is AP, AB, and C are coplanar, right? Correct?
Yes, sir.
Then again, I will do the same thing. R minus A can be written as some linear combination of A, B, and C. So T times B minus A plus S times C. And it will become like this. R is equal to A vector plus T times B minus A plus S times C. Nothing to remember here. The main idea is the concept. You need to know the concept of how we get the equations. There is nothing to memorize. अगर memorize करने जाओगे तो सब गलत हो जाएगा. Are you understanding how we are writing the equation on based on what? Whenever three vectors are
Yes, sir.
coplanar, we can write any one of them as a linear combination of the others. Another way to do the same equation would have been AP, AB, or C का box product is 0. Right? Box product is 0, then you can simplify it and it will look very different. it will look very different, but it means the same thing as this. I hope everybody is appreciating what I'm saying. समझ में आ रहा है सबको?
Yes,
Yes.
sir.
Case 3, the last case for plane is plane through 3 points. Now there is no parallel vector that is given. 3 points are given, but the concept is the same. The points are A, B, C. So I can make vectors with an unknown point P, which is R, and these are A, B, C. I can make one AP vector and one AB vector and one AC vector. You can make other combinations also, right? And these vectors are coplanar. And if they are coplanar, I will be able to write R minus A as T times B minus A plus S times C minus A. And that becomes your equation here. Nothing to remember, very obvious stuff. And now that you know how to write plane through 3 points, इतने तक समझ में आ गया सबको?
Yes, sir.
Sir.
Okay, we can also now check condition for
Sir, I have a doubt in
Hmm.
previous case.
क्या डाउट है बोलो?
सेकंड केस में, इससे पहले वाले में
ओके,
चेंज करना पड़ेगा। हाँ
बताओ।
सर इसमें जैसे मैंने मतलब हमने एक पॉइंट ए बी माना है, मतलब जो दो लाइन हमारे पास बन रही है, हम पी बी मान के भी कर सकते हैं ना, बस ये कंफर्म करना, मतलब उससे भी लाइन ही आएगी, लेकिन हमारे पास दो दो जगह आर आ जाएगा फिर।
हाँ, इक्वेशन थोड़ा सा डिफरेंट लगेगा, लेकिन कोई उससे दिक्कत नहीं है।
अच्छा ठीक है।
देयर इज नो इशू, द प्रॉब्लम विल स्टिल बी सॉल्व्ड।
यस
दो दो जगह आर आ जाएगा, लेकिन फाइनली कलेक्ट करके एक ही जगह ला सकते हो ना फिर।
यस सर, फिर डिवाइड करके मतलब कोएफिशिएंट डिवाइड कर देंगे तो एक जगह आर आ जाए।
उससे कोई चेंज नहीं हो रहा है, इट्स स्टिल द सेम सिचुएशन,
ओके।
but it looks better when you do it like this. That's why they're doing it like this. It
यस
looks better because you have only one R and the other one is B minus A, right?
यस सर, अंडरस्टूड।
There is no conceptual difference. The next thing is condition for coplanarity of 4 points. Suppose you have 4 points and somebody said that how do we decide whether they are coplanar or not? Now the method should be obvious to everyone by now. Tell me, what is the method, anyone? 4 points are given. How will you decide whether they are coplanar or not?
Sir, we will make 3 pairs of
Ah.
lines and they will be in the plane.
We will make 3 segments or 3 vectors, right?
Yes.
So suppose we make one vector like this, B minus A, another vector like this, C minus B, another vector like this, D minus C, right?
Yes, sir.
You could make any other 3 pairs also, right? We have to say that these 3 vectors are coplanar, right? How will you say that?
Sir, they will be linearly dependent. So we can represent B minus A equal to lambda times C minus B plus mu times B minus C.
We can always represent it like this, where L and M are scalars, right?
Yes.
Or another way to do it would have been box product of these 3 is 0, right?
Yes, sir.
Scalar triple product of these 3 is 0. That is another way to say the same thing, right? So everyone should understand that there is nothing to remember here. Don't try to remember stuff in this section, okay? The concept should be clear. If you try to memorize things, it will go wrong, okay? I hope everybody is following so far what we have done.
Yes,
Yes,
sir.
Yes, sir.
Okay, next thing. Now we will move to dot product and all, and we will look at some ideas there that you need to know very well. So 1 second, hold on. Okay, so some applications of dot product. Basic dot product stuff everyone is aware of, so I'm not going to discuss that. The first important application of dot product is when we write normal form of vector equation of a line. So this is a different form of vector equation of a line, vector equation of a plane. Normal form of vector equation of a plane. So understand this part. People are many times I've seen students who are confused by this. So let's say this is a plane, and let's say there is a direction that is perpendicular to it. This is the normal to the plane. Okay. Do you understand what this means? This is the vector that is perpendicular to the plane, right?
Yes, sir.
Okay. Now let's say origin was somewhere here. So basically, the perpendicular from origin to the plane will have length of P. P is the length of this distance. Basically, perpendicular from origin to plane has length P. Has length P. Why am I drawing the perpendicular in the same place as the normal vector? Because even if the origin was somewhere else and perpendicular was here, right? Even then, this vector has length P. It has the same direction as the normal, right?
Yes,
Do you
sir.
understand what I'm saying?
Yes, sir.
Origin कहीं भी हो सकता है. Perpendicular from origin to the plane should be parallel to the normal to the plane, right? Correct? So,
Yes.
if I call this point K, then I can say OK vector. OK vector is the vector from origin to the point on the plane, and it is like perpendicular to the plane. OK vector has magnitude of P, but the direction will be given by the n unit vector, right?
Yes,
Yes,
sir.
sir.
I hope everybody understands this much so far.
Yes, sir. Understood.
Okay.
Sir.
So now, क्या हुआ बोलो? Okay, nobody has any questions, then it's fine. So what we will say is, let's say we want equation of this plane. So what I will say is, let's say there is an arbitrary point, some r point with position vector r on the plane somewhere. So let's make a vector kr, right? kr जो segment होगा, you should realize that r vector का position vector is like this. This is my r vector. And k point is OK is this. This is the position vector of k, right? So what is kr segment? Kr segment is going to be OR minus OK, right? Is everyone understanding what I'm saying right now?
Yes, sir.
Yes, sir.
So therefore, it would be r vector minus p into n, right? Kr. Correct?
Yes, sir.
Yes,
And
sir.
now, once we have made this kr vector, I can always say that kr is perpendicular to OK. That is a fact. Correct? यहाँ पे 90 degree है because kr is a line in the plane. Right?
Yes, sir.
Since kr is a line in the plane, kr is perpendicular to OK. So we can now say r minus p n unit vector dot product with OK, which is p unit vector, should be 0, right?
Yes, sir.
So now I'll get r vector dot product with p n unit vector minus p square n dot n will be 1 is 0, right? And now
Yes,
I'm getting, see, p is a scalar, so dot product जब करते हैं तो scalar can be taken out, right? P r dot n unit vector, right, is equal to p square n dot n is 1. Correct?
Yes, sir.
Yes,
And now
sir.
I'm getting the equation r dot n is equal to p. And this becomes the equation of the plane in the normal form. Here, n unit vector is the direction of the normal to the plane, and p is the length of the perpendicular from the origin to the plane. Right? And if you extend this to Cartesian form, you can easily understand Cartesian form. You can say R vector will be a general point xi plus yj plus zk, and n vector का मान लो directions are li plus nj plus nk, such that l square plus n square plus n square is equal to 1. It's a unit vector. तो टेक्निकली एल एम एन विल बी डायरेक्शन कोसाइंस. अगर तुम लोगों ने थ्योरी पढ़ा है तो ये समझ में आना चाहिए.
Yes, sir.
So then you will get what? When you do dot product, you will get immediately Lx plus My plus Nz is equal to P, and P here is the length of the perpendicular from the origin to the plane, and Lmn are direction cosines of the normal to the plane. Is it clear so far what I am saying here?
Yes, sir.
You
Sir.
might have seen this equation in 3D also, right? The way it is connected, you have to see the connection, how it is actually the same thing that we are doing here, right? Now, we can extend this and get some corollaries to this. For example, you can say that vector equation of a plane normal to n and passing through a point A vector is what? कैसे निकालेंगे? So I will do the same thing, nothing major. Normal is this vector. This is perpendicular to the plane. I already know plane passes through a point A, and I will take a random point P on it which has coordinates R, and I will say AP, the line AP is in the plane. So R minus A is obviously dot product with n should be 0, no?
Yes, sir.
R minus A is a line in the plane and it will always be perpendicular to the n. So R minus A dot n is 0. So you'll get R dot n is equal to A dot n. Nothing to remember. These are basic concepts. Okay. So that will be your equation of a plane normal to a vector and passing through another point. Then one thing that you should know is this
Sir,
side.
wait 1 minute, sir.
Tell me.
Sir, in the last page that you have done, the normal form, here P was representing the perpendicular distance from origin, right?
Right.
If we don't know that form, then how can we conclude from this form? Because I have not seen, for the very first time that I have seen that form equal to P, where P is representing the perpendicular distance from origin. I know this form R minus A dot n cap equal to 0. So if I don't know that, how can we, like, if the question is framed कि परपेंडिकुलर डिस्टेंस P रहना चाहिए और हमें प्लेन निकालना है, तो फिर इस फॉर्म से कैसे उस पे जा पाएंगे? मतलब अगर हमें वो अगर आइडिया नहीं लग रहा है, वो क्लिक नहीं कर रहा है, तो इस फॉर्म से वो सवाल
तो
कैसे बना?
यही ना है perpendicular distance. This is the perpendicular distance from the origin to that. इसीलिए तो थियरी बता रहा हूं कि वो आइडिया क्लिक कर जाए. नहीं कर रहा है मतलब नहीं कर रहा है, तो फिर इसीलिए तो बता रहा हूं कि कर जाए. अभी समझ में आया था वो फॉर्म कैसे आया?
हाँ, यस सर.
अभी समझ में आ गया है ना कैसे आया?
यस सर.
तो अब से उसको यूज करना है. उसमें कॉन्सेप्ट, इसमें बेसिक कॉन्सेप्ट है. ऐसा एक प्लेन है, अननोन प्लेन है. We know that perpendicular from origin to that plane is length is p, and normal to the plane has direction n vector. Obviously, I can say that this point k, OK, will be p n unit vector, right?
Yes sir.
Yes, sir.
And then you can say that any random point r which is having coordinates r, rk will be perpendicular to this n, or rk will be perpendicular to OK. So we'll say R minus Pn dot product with Pn. It's literally the same thing. वही तो है जो अभी किए थे.
यस सर ठीक है
समझ में आ रहा है कि सेम ही है.
हाँ सर
अभी भी तो वही कर रहे हो ना. R minus A dot n is 0.
यस सर
बस बात यह है कि वहां पे ओरिजिन से परपेंडिकुलर का लेंथ भी दे दिया गया था और बोला गया था, और यहाँ पे बोलते नहीं है लोग, लेकिन बात तो वही है अंत में.
यस सर
The point is not to memorize all these forms. The point is to understand the logic of it. You can do it, the derivation yourself, if you understand the logic. Right?
sir
The next point that I want to talk about is find the equation of the planes that passes through point passing through point A vector and also through the, or you can say that passes through point this and is parallel to the line of intersection of two given planes. So यहाँ पे मैं बोल रहा हूँ कि टू प्लेन्स का इक्वेशन दिया हुआ है. R dot n1 is equal to q1 and R dot n2 is equal to q2. Let's say these two equations are given. So you have learnt in basic conics, basic straight lines and all also family of lines concept, right? So family
Yes,
of lines concept was what? L1 plus lambda L2 is equal to 0 will be the equation
0.
of all possible lines through the line of point of intersection of these two, right?
Yes,
Correct?
sir.
So what we can say here we have two planes. Any two planes always intersect in a line. ये concept पता है ना?
हाँ सर
Yes, sir.
You can see that this is plane 1, this is plane 2. The line of intersection is there, no? Correct? Let's call this line L. What I want is a plane that goes through this line L. Okay? Or is parallel to this line L. Line L is lying in the plane maybe, right? So imagine, यहाँ पे visualize करो, there are infinite planes through this line, no?
Yes, sir.
There are so many possible planes that go through this line, right? We
Yes.
need one specific plane that also passes through this point, right? Correct?
Yes, sir.
So first we will write the equation of the family of planes through the line L. Through line L. What is special about line L? Line L was the intersection of these two planes, right?
Yes, sir.
So family of planes का equation होगा R dot n1 minus q1 plus lambda times R dot n2 minus q2 is equal to 0. सबको समझ में आ रहा है क्या कर रहे हैं?
हाँ, sir.
This is a family of planes that is going through the line of intersection of the two planes, right? And it will represent different planes depending on the value of lambda. Correct?
Yes, sir.
Okay, now from here, what I have to also ensure is that whatever plane I have, it will pass through A, no? Correct?
Yes, sir.
So let's do it on the next screen. First, I will write the family equation. Family equation is R dot n1 minus q1 plus lambda times r dot n2 minus q2 is equal to 0. Let's make it a little simpler, this equation only. So let's write it like this: r dot n1 plus lambda times r dot n2 minus q1 minus lambda q2 is 0. And we can combine this and say it is r dot n1 plus lambda n2. I hope everyone is agreeing that this can be done.
Yes, sir.
This is the same, this is family of planes through L. Correct? What is L? L is the line of intersection. Is everyone following so far?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now I have to say that this, I don't need the entire infinite set of planes. I only need one particular plane out of this family, right? I need the plane that passes through a vector, right? So how do we check
Yes.
whether a plane passes through a vector? We can put a vector instead of the variable point and say that the equation should be satisfied, right?
It will satisfy the equation.
घंटा का value आ
Right.
जाएगा, sir.
So we can say a, let's put a here and we'll say a dot n1 plus lambda n2 should be equal to q1 plus lambda q2, right?
Yes,
Correct?
sir.
And from here, if I solve to find the value of lambda, that is the particular lambda that I need in this equation, right?
Yes, sir.
So how do I solve for value of lambda? It is very easy because it's a dot product. I will just collect all the terms together for lambda and all. So I'll say a dot n1 plus lambda a dot n2 is equal to q1 plus lambda q2, right? Notice that यहाँ पे q1 q2 were scalars, right?
Yes, sir.
Yes, sir.
So solve कर सकते हैं आराम से, कोई दिक्कत नहीं है. यहाँ पे we'll just collect lambda one side and solve for it. So we will get basically this. Lambda a dot n2 is a scalar, so no issues. Minus q2 is equal to a1 minus a dot n1, right? So lambda is equal to a1 minus a dot n1 divided by a dot n2 minus q2. बाय द वे ये मैं a1 लिख रहा हूँ, ये एक्चुअली q1 है, यहाँ मैंने कंफ्यूज कर दिया है. समझ रहे हो ना, ये q1 है, a1 नहीं,
Yes.
राइट?
Yes.
और सब सही है. हाँ, so this is my thing. See, I have gotten the value of lambda. Why is this known? Because everybody, we already knew the original plane equation. So we knew n1, we knew q1, we knew n2, we knew q2. This is given in the question. And we also know a vector. So this is completely known constant now, right? And therefore,
Yes, sir.
now my required equation will come if I put this value of lambda, if I put inside this, that is my equation of the plane. अभी हम लोग बहुत जनरल क्वेश्चन को कर रहे हैं, इसीलिए लग रहा है कि बहुत कॉम्प्लिकेटेड है. बट in a real question, you will realize that all of this process is not very difficult when you actually calculate it. Has everyone followed what I did right now?
Yes.
Yes, sir.
Yes, sir.
Okay. Now, using the same ideas, can you tell me, or can you think about what to do here? Suppose there is a point A with position vector A, and there is a plane r dot n is equal to q. This is a plane. Now, what I want is perpendicular distance from point A to the plane. How do I find this? I don't need a फॉर्मूला. फॉर्मूला तो सबको पता होगा, लेकिन फॉर्मूला नहीं बताना है, एक्सप्लेनेशन बताना है कैसे निकालेंगे. अगर कोई फॉर्मूला याद नहीं है तो क्या करोगे? फॉरगेट द फॉर्मूला फॉर अ मोमेंट, थिंक अबाउट कि बिना फॉर्मूला के कैसे निकालोगे. This is a plane, this is a point, and a perpendicular distance from the point to the plane. क्वेश्चन तो क्लियर होगा सब. हाँ, डॉट प्रोडक्ट सही है, लेकिन कैसे, क्या चीज करोगे, स्टेप्स बताना है मुझे, फॉर्मूला
सर
नहीं
एक
बताना है.
सर एक पॉइंट ले लेंगे प्लेन पे,
हम्म.
और उस पॉइंट को ए से ज्वाइन करेंगे.
हम्म. तो कहाँ पे लो, कहीं भी रैंडम पॉइंट.
हाँ, रैंडम लेके और फिर उसके बाद उसको डॉट प्रोडक्ट करके, मतलब वो परपेंडिकुलर हो जाएगा
नहीं, ये
हमें पॉइंट
परपेंडिकुलर
की.
कैसे होगा, देखो रैंडम पॉइंट से तो परपेंडिकुलर नहीं होगा ना. हमें चाहिए.
सर नॉर्मल वेक्टर के अलोंग लेंगे वो पॉइंट.
तो कैसे लेंगे बताओ फिर, कैसे करोगे. हमें चाहिए ये डिस्टेंस, राइट. तुमने जो अभी बोला है वो ये रैंडम पॉइंट हो गया, राइट.
सर हम फुट ऑफ परपेंडिकुलर लगा के क्यू पॉइंट निकाल सकते हैं.
हाँ, वही तो मैं बोल रहा हूँ, फुट ऑफ द परपेंडिकुलर लगा के जो तुम बोल रहे हो, मतलब क्या है उसका.
सर प्रोजेक्शन यूज कर सकते हैं क्या पीए वेक्टर का EQ के अलावा?
हाँ, कर सकते हो, जो भी यूज करना है कर सकते हो, लेकिन मुझे स्टेप्स बताना है, ऐसे नहीं बताना, फॉर्मूला नहीं बताना है. स्टेप्स बताओ क्या क्या करेंगे. देखो, तुम जो बोल रहे हो
सर
प्रोजेक्शन, उसके लिए तुमको ये पॉइंट जानना जरूरी होगा ना.
हाँ
तो ये पॉइंट तो अभी पता नहीं है ना, कोई रैंडम पॉइंट बोल लो.
सर मैं बोलूँ.
हाँ,
सर
बोलो.
जैसे हमें प्लेन का नॉर्मल वेक्टर पता है,
हम्म.
और हम नॉर्मल और एक पॉइंट से पास करता हुआ लाइन लिख सकते हैं, तो वो
हाँ,
लाइन एक ही हो जाएगा.
first step is writing a line AQ, which is a line through point A and through point Q, which is parallel to the normal, right?
यस.
This line has to be perpendicular to the plane. Since we need perpendicular to the plane, it will be parallel to the n vector, right?
यस सर.
So line AQ का equation क्या आएगा? By line concept, we can say R minus A is equal to T times n, right?
यस सर.
Okay, so my line AQ is R is equal to A plus TN, right? अब हम लोग को निकालना है कि प्लेन और लाइन का इंटरसेक्शन कहां पे हो रहा है, राइट.
यस सर.
सो प्लेन का इक्वेशन तो ये है ना.
हमें सेटिस्फाई करते हैं.
हम लोग को दोनों इक्वेशन को सॉल्व करना है, राइट. करेक्ट नो.
हाँ सर.
ये दो इक्वेशन को अगर सॉल्व कर लेंगे तो आर पता चल जाएगा, राइट. इज एवरीवन अंडरस्टैंडिंग व्हाट आई एम सेइंग राइट नाउ.
Yes,
यस
sir.
सर.
सो इन दोनों इक्वेशन को सॉल्व करके हमको आर पता करना है, द इंटरसेक्शन पॉइंट ऑफ दिस लाइन एंड दिस प्लेन. उससे फुट ऑफ द परपेंडिकुलर भी निकलेगा और उससे लेंथ ऑफ परपेंडिकुलर भी निकलेगा, राइट. सो हाउ डू आई डू दैट. सो टेक द आर फ्रॉम हियर एंड पुट इट इन दिस. सो व्हाट वुड आई डू, a प्लस t टाइम्स n डॉट प्रोडक्ट विथ n इज इक्वल टू q, राइट. करेक्ट.
सर.
यस सर.
उससे क्या आ रहा है, उससे आ रहा है a डॉट n प्लस t इंटू मॉड n स्क्वायर इज इक्वल टू q, राइट. और उससे हमारा t वैल्यू आ रहा है ना, t वैल्यू इज इक्वल टू q माइनस a डॉट n डिवाइडेड बाय मॉड ऑफ n स्क्वायर.
यस सर.
यहां पे लिख रहा हूं t इज इक्वल टू q माइनस a डॉट n डिवाइडेड बाय मॉड ऑफ n स्क्वायर, राइट. I hope everybody has understood what I have done so far.
Yes, sir.
यस सर.
अगर t वैल्यू पता चल गई तो ये पॉइंट तो पता चल गया ना, इसमें डालना है t ना.
Yes, sir.
तो पॉइंट कहाँ, q पॉइंट का लोकेशन होगा a प्लस t टाइम्स n. सो q माइनस a डॉट n डिवाइडेड बाय मॉड n स्क्वायर टाइम्स n वेक्टर, दैट इज योर लोकेशन ऑफ q. इज एवरीवन अंडरस्टैंडिंग.
Yes, sir.
Yes, sir.
यस सर।
अगर Q लोकेशन पता चल गया तो पहले तो फुट ऑफ द परपेंडिकुलर आ गया हमारा, और फुट ऑफ द परपेंडिकुलर अगर आ गया तो बस AQ का मैग्नीट्यूड निकालना है, राइट?
Yes, sir.
तो हम लोग करेंगे कि AQ का लाइन सेगमेंट का मैग्नीट्यूड होगा, इसमें से A वेक्टर घटाना होगा, राइट? We will subtract A
Yes,
from
sir.
here. We will get basically just this much will be remaining, no? Is everyone
Yes, sir.
understanding that AQ line segment will be in this form? Q minus A dot n divided by mod n square multiplied by n vector, right? And I need to take magnitude of this. So I will write it on the next screen. It will be Q minus A dot n divided by mod n square multiplied by n vector का mod लेना है, right? और by the way, Q was not a vector, Q was a scalar. So notice ये part तो पूरा scalar है, इसको तो बाहर निकाल लेंगे, right?
Yes.
और अंदर में क्या है? mod of n vector by mod of n square, right? So technically this is mod of n. यहाँ पे ऊपर में mod of n एक बार आएगा, right? और नीचे में दो बार है, right? So ultimately final answer will become Q, length of the perpendicular is Q minus A dot n divided by mod of n.
Yes, sir.
समझ में आ रहा है कैसे आ रहा है ये?
Yes, sir.
एक चीज नहीं समझ आई सर, वो
क्या?
जो आपने AQ लिखा है ना, वो नहीं समझ आया पीछे वाले पेज में।
AQ लिखा है, नहीं समझ में आया? मतलब कैसे नहीं समझ में आ रहा, बताओ।
हमें R वेक्टर मिल गया था, जो T को सब्स्टिट्यूट करके किया, तो R मतलब R वेक्टर क्या है, हमारा पॉइंट Q है।
R vector is a position of a random point on the line. अब T का
Yes.
ऐसा वैल्यू लिया है कि वो Q बन जा रहा है, राइट?
हाँ, तो
तो
Q
A प्लस T टाइम्स n, ये लिख रहे हैं Q वेक्टर का लोकेशन है ये, राइट?
ये सर।
तो अब AQ वेक्टर क्या होगा सेगमेंट? Q माइनस A ना,
हाँ,
तो उसमें से A घट जाएगा ना,
अच्छा, हाँ, ये सर, ठीक है सर।
तो बचेगा बस इतना ना।
सर, समझ गए।
Is everyone understanding?
Yes, sir.
Yes,
यस
sir.
सर।
What I want you guys to do is notice that ऐसा फॉर्मूला होगा, तुम्हारे बुक में भी होगा, ये सब फॉर्मूला देखे होगे पहले, बट खुद से फॉर्मूला डिराइव करने की एबिलिटी होनी चाहिए, तभी जाके कॉन्फिडेंस आएगा चैप्टर में। अभी ये फॉर्मूला डिराइव हो गया, राइट? What I want you guys to do is now do some PYQs, vectors and both vectors and 3D. अभी थियरी पूरा खत्म नहीं हुआ है, but I will do it in the next class. Okay? We will do 1 or 2 more classes for theory for whatever is left. अगर तुम लोग बोलोगे कि थियरी हो गया है, तो then I will start doing problems. Do
सर,
you understand what I'm saying right now?
ये सर।
Yes, sir.
When you guys feel confident, what you need to do is the sheets that I have sent, you have to solve that sheet first of all. And if you are done with that sheet, you can also do PYQs. If you guys are feeling confident, then we will discuss problems. But the next 1 or 2 classes, I want to do theory only. So a little more theory will be done. Okay. So करते रहो, मेहनत करो, और video will be uploaded on YouTube. You can watch it again if there is any confusion. Okay.
Okay, sir.
Okay, sir.
सर,
और
एक डाउट रह गया।
बोलो।
सर, जैसे स्टार्टिंग में मैंने बोला था कि कोई भी एक रैंडम पॉइंट ले लेते हैं, अगर हमें केवल परपेंडिकुलर डिस्टेंस निकालना है, तो हम उसका जैसे प्रोजेक्शन लेके कर सकते हैं ना, वो आइडिया
हाँ,
कैसे?
कर सकते हो, वो भी सही आइडिया है, बट उसमें रैंडम पॉइंट तुमको खुद से चुनना पड़ेगा ना फिर।
हाँ,
यहाँ पे रैंडम पॉइंट तो दिया हुआ नहीं है ना क्वेश्चन में,
नहीं दिया है।
तो तुमको प्लेन के इक्वेशन को देख के एक पॉइंट देखना पड़ेगा जो प्लेन पे लाई करता है, समझ रहे हो?
यस।
प्लेन का इक्वेशन अगर गिवन है तो यू कैन फिगर आउट अ पॉइंट ऑन द प्लेन एंड यू कैन से दैट दिस वेक्टर इज माय रैंडम वेक्टर व्हिच विल बी r minus a, and you need to take projection of that along the normal direction, right?
यस सर।
तो वो भी मेथड सही ही है, लेकिन ये पॉइंट अननोन था इसलिए वैसे नहीं कर रहे हैं अभी।
अच्छा, ठीक है, ठीक है सर।
लेकिन अगर पॉइंट ऑब्वियस है कि दिस पॉइंट लाइज ऑन द प्लेन, तो अगर ऑब्वियस होता तो करते वैसे फिर, राइट?
सर वेक्टर फॉर्म में मतलब जैसे आर पॉइंट जैसे यहाँ पर एक वो था, तो हम आइडेंटिफाई कैसे करेंगे? जैसे हमें अगर कोई लाइन गिवन है x+y=1, तो उस पे हम पता कर ले जाते हैं कि उस पे कौन सा पॉइंट होगा। मतलब बहुत सारे पॉइंट होंगे तो
तो
1,
ये वेक्टर फॉर्म में है, तो ऐसा थोड़े है कि तुमको कन्वर्ट करने नहीं आता इस कार्टेशियन फॉर्म में।
अच्छा, कार्टेशियन में कन्वर्ट करके फिर सोचेंगे।
बहुत आसान है ना कन्वर्जन। अगर मान
ये
लो n वेक्टर दिया हुआ है और r डॉट n है इज इक्वल टू सम कांस्टेंट, तो ऑब्वियस हो गया ना, lx प्लस my प्लस nz प्लस p।
अच्छा, हाँ सर, ये सर।
प्लेन का इक्वेशन तो ऑब्वियस नहीं हुआ।
ये सर ठीक है।
अगर ऐसा इक्वेशन आ जाता तो फिर तो कोई जीरो जीरो डाल के कोई एक पॉइंट तो ढूंढ ही लेते ना।
हाँ सर।
मान लो एक इक्वेशन ऐसा दिया हुआ है 2x प्लस 3y प्लस z इज इक्वल टू 2। I can always find some random point on the plane. Take y and z 0, x is equal to 1. So 1 comma 0 comma 0 is on the plane, right?
हाँ सर, क्लियर है सर, अब आइडिया क्लियर।
तो फिर प्रोजेक्शन लेके कर सकते हो, लेकिन डायरेक्ट भी कर सकते हैं जैसे हम लोग ने किया, right?
हाँ, ये सर।
Okay, so what I want you guys to do is PYQs करना है, sheet you have to solve, the sheet that I have shared, you should already start it. अगर theory में doubts है तो work on the theory and watch the video if there is some confusion. You can watch it again on YouTube. And otherwise playlist मेरा है, उसमें भी देख सकते हो, ये सब discussed है playlist, ठीक है? The point is we will finish the theory in 1 or 2 more classes. After that we will focus on problems. But also, like, if anybody has not done the test, please do the test. I want to discuss the test with you guys. I will call you separately and discuss it, okay? So if you have not done the test, please do the test. Send me your scores, okay? Okay, और कुछ नहीं है अभी, अगली क्लास में फिर डिस्कस करते हैं, ठीक है?
Okay, sir.
जिन्होंने टेस्ट कर लिया है तो अच्छा है, अपना वेक्टर्स और 3D पे काम करो, ठीक है? ओके, आई विल सी यू नेक्स्ट टाइम देन।
Thank you, sir.
बाय।
ठीक है सर।
बाय सर।
Thank you, sir.